and welcome to this session in our titration video series. We're going to be discussing some topics around exactly where you might want to enforce policy for your application workloads. We know it's a topic that has been discussed a lot, and there are a lot of options available out there to you in terms of where you might want to enforce policy and the type of policy that you might want to enforce at those different points. So I'm Tim, and I'm joined by Remi, and we're going to be doing some whiteboarding around the different places that you can enforce policy for your applications.
Sounds good, Tim. First question before you even get into whiteboard. Why does it matter?
That's a good question, Remi. I wish it didn't matter, but the reality of life is there are different places that make sense to enforce different policies because each one has pros and cons. There are some things that make sense to do on the application or on the workload. There are some policies that make sense to enforce in the network, and it's really down to exactly what you want to do with those policies. How granular do you want them to be? How scalable should they be? And how efficient should those policies be to enforce?
Okay. Is there some form of rule of thumb or something I can maybe apply?
So if you don't want to watch this whole video and you want the easiest rule of thumb, I would say if you want to enforce policies that are granular microsegmentation policies in a scalable way, the easiest place to go for is the host. But if you're looking at north to south policies that come in and out of a data center, it makes sense to put those on a physical file at the edge of the data center. If you want the 2-second nugget on how to do it, that's the easiest way to go for. But we're going to explore a little bit around those different design choices and why you might want to choose those points of enforcement.
Okay, sounds good. So what do you think we draw a quick diagram and we kind of take it from there?
Let's do that.
Okay.
I want to see some of your artistic skills today.
I'm going to give you some perfect squares and rounds again.
Okay.
So that's a cloud, okay?
Okay.
Okay, it's abstract.
It's an abstract cloud.
So we're going to go through and let's say you talked about north-south, right? So
yeah.
Let's say that we add a firewall here.
And when we say north-south, we mean traffic entering or exiting the data center, right? Or the cloud.
Yeah, actually you're right. That maybe I should draw a little boundary to show where's the DC and where's the rest of the environment. So let's say that the black square-ish is a data center.
It's close enough.
Let me just put a little note just for you not to forget.
And when we say data center, we mean either a physical on-premises data center or potentially even a public cloud provider where you're hosting application workloads.
Yeah, absolutely. Okay. Actually, maybe we can even draw the cloud after.
Okay.
Let's see if we can add on to that. And let's say we have here another cloud. This one would be internet. And let's just say campus. Titration is a DC product, right, Tim?
Yes. Although it has visibility into the campus and provides identity from it, right?
Okay. So we have those, and let's go to the DC edge. I mean, they probably would be different firewalls, but let's just simplify it for sake of this demo. And let's add maybe a switch. And a bunch of workloads.
Okay, makes sense.
Fairly simple DC. I mean, I don't think it's a real representation of a DC, but at least as simple as we can get to talk through there. So I have a few things I'm trying to protect against here, right? Mm-hmm. Where should we start? Let's start bottom up. What do you think?
Why not?
So first thing, I want to stop traffic going from one workload to another.
Okay.
So what's the data path for that one?
Well, assuming that we don't have some virtualization in play here, the data path is going to be from the workload on the left-hand side to the right-hand side via the switch.
Something like that?
Yes.
Okay.
Yeah.
And then from this one to this one, same thing, I guess?
Yep.
Okay. So if you're looking at those traffic flows and you were to enforce on the switch, do you see any concerns of doing that?
So my major concern is it might work right now with the few workloads that we have there, but as we scale out, if I'm doing very, very detailed rules, it could start to get to the point where there's more rules than that switch might be able to handle. Does that seem reasonable?
Oh, so you're saying if I have, this workload might have 100 policy, this workload might have 100 policy. Unique, let's say, and we were talking micro-segmentation, so one host has his own sets of policy in there. And you're saying that here, so then I would have 200 here for just 2 hosts.
Yeah.
Okay. So the problem would be at some point, I guess, 2 problems. One is the manageability of that. Like, we've all logged into a file with 1 million ACLs.
Yeah.
We know how great that is. The second point is that, obviously, at some point, there's so many rules to process that, I mean, it will have some form of performance impact. Whatever the box is, I mean, there's no magic. Something we'll have to enforce at some point.
Yes.
Okay. So for these kind of policies, where should we enforce them, you think?
So for those very detailed micro-segmentation policies, those policies that really describe the application behavior, I think we could probably optimize that out and bring it as close as possible to that workload and enforce it right there on the workload, right?
Okay. So we're saying that anything that's from host to host inside the data center is actually better enforced on the host directly.
Yep.
Okay. So now we don't have 200 anymore here, we have 0.
Yep.
Okay. So let's imagine now, let's add a bit more complexity here. Let's say that those 2 guys are part of Active Directory, for example. Let's say that. Actually, Active Directory is a bad example. Let's take a backup server.
Yep.
Because we all love backups, right?
Yes.
When it kicks
you have
in.
to do your backups.
You have to do your backups. Makes me think about crypto problem recently. But anyway, so if we want to send that to the backup server, what's the kind of rate of traffic you're thinking for backup?
I think backup traffic is going to be very high volumes of traffic, but it's also going to be pretty predictable, right? It's always going to be pointing to that same backup server, and it's going to happen maybe every night at the same time, same place, right?
Yeah, that seems about fair. So what if we were to do something like, allow Annie on the switch to talk to the backup servers?
Yeah, that makes sense.
So that would be pretty cool. The switch is going to handle the big load of the traffic, and they're ASIC driven, so that's like nothing for them.
Yep.
So they'll just handle that easy. And does that mean that the software sensors that's running on the backup server would actually just see clean traffic?
Yes.
Okay.
Yeah, that seems like a good way to get the efficiency of what the switch is really good at, which is dropping those packets in hardware or allowing those packets in hardware. But because we're generalizing that policy and saying every workload can access the backup server, it's going to be a lot less than that 100 policies that we might have for a micro-segmentation policy.
So will we still keep every server having the policy to go to the backup server?
Yes.
So here I would have 1 here, 1 here, 1 here?
Yeah, it makes sense to use a defense in depth strategy. If you have 1 layer or 2 layers or 3 layers of segmentation, each one is going to provide an extra safeguard against someone getting deeper into your network.
Okay, I mean that makes total sense in there. So here what I'll have 1 layer, the host is going to enforce his source IP to the backup servers. The firewall is going to enforce, the switch, is going to enforce the traffic from all the workloads up to the backup servers. The backup server can then allow traffic only for the specific endpoints it wants to receive traffic from.
Yep.
Is that a good example where we would actually define a policy based on a process hash?
We could definitely define it based on a process hash, yeah.
So you could enforce if the agent is running on the server, then it can talk to the backup servers.
Yep.
But at the switch level, it doesn't matter. The switch says, you know what, any hosts that are in my segments can talk to the backup server over these ports.
Yep.
Okay. Does that pretty easy so far?
Yeah, it seems easy, and it seems a good way of using the right resources that you have available to you.
And as we discussed in the scope modules, right, is we can figure out our scope structure in a way that can allow us to do that, right?
Yeah.
Okay.
We can go from the very generic high-level policies that might actually allow a big group of workloads to speak to a particular service, and then get more refined in the policies lower in the scope tree that define the individual application set of rules.
Okay, that's pretty easy.
Yeah.
So now let's take another example. Let's take, for example, campus accessing, let's say now this guy is, we're going to promote a server to your favorite OS. This guy is now AD.
Okay.
It's a Windows Server, Tim.
Yes.
I know you love it. So connection from campus to AD, through firewall, through switch, down to AD. There's a pretty high chance everyone will use AD. I don't know what you think, but except you have a Mac. But.
Except me, but it seems like AD is definitely out there in every environment.
I see. So here, what do we want to enforce? We want to enforce campus to Active Directory. I'm looking at that. We probably want to enforce as close as possible to the campus.
Yeah.
So maybe firewall edge?
Makes sense. That's a policy that really would make sense to put on the edge, especially because we can define the campus in a large group of endpoints, and then we can ensure that we're not allowing any traffic in towards AD that isn't specific to that campus.
Sounds good. So in short, here I would probably define my filters based on subnets.
Yes.
Yeah. So if you define your filters based on subnets, then basically you're going to filter out all the traffic coming here, and you're doing a first pass. I think that's the idea, right?
Yeah.
You can still continue enforcing at the host for specific services. Maybe a Linux workload doesn't have access to AD.
Yes.
So we want to block that here, for example.
Yeah.
So that's pretty straightforward still.
Yeah.
Next scenario, internet going to a host. What do you think, Tim?
Well, for sure, seeing as this is north to south traffic, it makes sense to enforce some of that on the firewall, right? Internet, can we trust the internet?
Of course, Tim.
You might trust the internet. I'm a little bit less trusting. Once you expose a service to the internet, you really don't know what's going to be hitting you, right? People could be trying to scan you. People might be probing for some sort of vulnerability. It makes sense to have a firewall, a real firewall at the edge of that traffic stream to make sure that you're doing a first pass on it to ensure that it's legitimate traffic.
Okay. So you'd recommend putting the policy here. Sounds good. So policy at the firewall level. What if now we add a bit more fun to it? Let's say the firewall has a Citrix, actually, connected to it.
Yep.
And because obviously those boxes are hardware boxes, so they're kind of more designed to be able to handle load and stuff like that. And let's say I have a traffic that does this and then goes down somewhere inside the DC.
Yeah.
I guess I'd put a policy on the firewall as well here.
You could put a policy on the firewall, but also I think the Citrix could be a good place to enforce that policy as well.
So you think that what we could do is actually set the ACLs on Citrix directly and automatically so that we actually protect the traffic before it even hits the Citrix box?
Yeah.
Before it actually hits, the backend?
Yes.
Okay. All that integration?
All of this integration.
Okay. So I can go and I can click enforce, and the enforcement is going to actually render the policy that needs to go on the Citrix here on that box, and it will use the Kafka stream to stream out what needs to go anywhere else in the network, the full policy view.
Yeah, that's correct. So we discussed in this diagram that there's lots of different places to enforce policy. And that policy can be natively enforced on the host with titration, but we understand that that's not the only place that you might want to enforce, and that's why we give you some other options. So we do have native integrations with load balancers, like Citrix and F5, but we can also push that policy out in an open format so that it can be ingested by firewalls, like an ASA or an FTD.
Well, that's pretty cool. So all that can be completely automated.
Yeah, and the best thing is that you then have one single source of truth. You have one policy set held within inside one policy orchestrator that can then be optimized into different versions of that same policy truth to decide exactly what you are going to force in the different points in the network.
That sounds fair. Now a question. We talked quite a bit about Identity Services Engine in different modules across the videos. Is Identity Service Engine an enforcement point?
The Identity Services Engine is not the enforcement point for the titration policies. We use it as identity. It makes sense, right?
Yes,
but we then actually go ahead and enforce that policy somewhere in the data center. Now, depending on the type of policy enforcement that you want to do, it might make sense to do it on a network device, or if we're going to more granular micro-segmentation levels of policy, it really makes sense to start putting those on the individual application workloads. If I want to restrict only administrators to access certain workloads via SSH, that's going to be something that is continuously updating as and when administrators move around. And that doesn't really make sense to put in the network. Networks typically are advised to change their policies in a slightly more slower refresh cycle, whereas we can update policies in software on the host very, very quickly.
I see. So your point is, would you allow this through the firewall? Yes, you'd say probably all campus is allowed to access all servers in that case.
Yes.
But based on the user actually logged into that machine, I will only allow access, for example, to SSH on this guy, or web on this guy, or a VIP on this guy.
Yes.
Okay.
Yeah. So you still get that defense in-depth strategy. You ensure that the traffic that's coming into the data center is actually from the campus, and you can do that well in hardware on a firewall or a switch. And then you can later go and define exactly who that user may access after they get into the data center by enforcing that on the individual hosts.
Oh, that sounds cool.
Yeah.
There's another thing I just picked up from what you were saying. You mentioned the rate of change.
Yeah.
So I understand some policies would be a high rate of change, low to medium volume. Others would be low rate of change, high volume. Which ones do we enforce where?
So high rate of change, that could be very, very high rate of change, especially if we're talking virtualized workloads or even more containerized workloads. We could be talking about policies that need to be updating constantly. Now, what we found from experience is most administrators don't want to be updating those policies continually on network devices. Network devices typically have change windows when those policy changes can be made. Whereas at the host, because it is much more dynamic and flexible, you can push those policy changes out very quickly. However, the type of traffic that we expect to be enforcing inside those policies needs to or should be recommended to be somewhat lighter traffic, not your heavy traffic like backups. Whereas if you have traffic like we were discussing earlier, the backup traffic, everyone is going to be using that same policy. You're not going to be changing your backup servers frequently, and it's going to be a very high volume of traffic that's reaching that backup server. Those kind of policies, yes, they do make sense to also replicate into the network.
That sounds pretty easy in that sense. So
yeah.
High volume, low rate of change, firewall, or switch, or wherever you really want. We don't really care. Low to medium volume, high rate of change on the host directly.
Yep.
And you can overlap them, right? It's just, I guess our recommendation is always, if you're putting one policy, don't put the exact same policy in two places.
Yeah.
Because otherwise, waste of resources.
Waste of resources.
So that's not very easy. So in there, firewall, change management. So in this case, I would set all campus to all data center, and then for the individual workloads, then I'll go down.
Yeah.
Okay. Sounds pretty clear to me, yeah, up to now.
Yeah. And it might be that in a customer environment, there already is a firewall that's controlling traffic coming in from the campus. There may already be some zone-to-zone based policies in the switch. So if you're just getting started with titration, don't worry about doing all of this or exactly where you're going to enforce. We really would advise that the simplest way to get up and running with segmentation is to utilize that host-based enforcement. But as you start to become comfortable with that and you want to advance the policies that you're enforcing, that's when we would start talking about these topics about where you can synchronize policy and the different types of policy to enforce in those infrastructure devices.
There's actually another topic I was more thinking than on the operational side of things. Are we saying that this policy has to be microseg, or can I put subnet to subnet on the host?
No restrictions at all. Doesn't have to be microseg. Could be subnet to subnet policies. It really comes down to the level of policy that the end user wants to enforce on those workloads.
I see. So I could say, for example, I just bought iteration, getting started right now. What should I do? I can't boil the ocean down and just go microseg day one. I mean, I can try, but I don't know anyone who succeeded. I don't know for you.
You know, I've seen successful projects very quickly with microsegmentation in limited chunks, but boiling the ocean overnight, yeah, exactly.
Okay, so avoid the boiling the ocean, go in stages. And so would one stage be, for example, you know what, campus is, I don't know, let's say 10.0/8, and we just basically set policies on how campus is actually accessing workloads based on the 10.0/8 as a starting point.
Yeah, those kind of starting policies, the very basic high-level policies that just ensure that you have good data center hygiene. Things like production workloads shouldn't speak to non-production workloads. Those types of policies can actually even be implemented before you do microsegmentation, and they really are very good to enforce at the host as well.
So you'd be fine with that, saying, okay, you know what, we're doing 10.0/8. We're not going to touch the firewall because firewall most likely has some policy in places here. We don't want to interfere with that. We don't want to touch the switches neither. We don't want to go into change request story and so on. But we will put send 0/8 to this IP address will actually get enforced there. Whenever the customer feels comfortable with this approach and he thinks it's about time to bring it to the next level, then they can look at, okay, how can we use platforms to go and translate policies for firewall switches, whatever else.
Yeah, I think we've probably both found that if you're looking for the biggest bang for your buck, the biggest time to value when it comes to just applying some level of segmentation, if you want to go from a lack of segmentation to something being segmented, go for those easier zone-to-zone based policies. And when you do it at the host, it doesn't require ripping and replacing any physical hardware. It doesn't require making any changes in your infrastructure, but you can effectively start to tighten the screws on the traffic in your environment.
That's pretty cool. Well, I see that, by the way, from here. How would you handle, because there we're talking about things, all of those can support agents in our discussion here.
Yes.
What if I had this guy? And that's a mainframe. Like a real deal mainframe. Like, I mean, the thing that's there and that's there to stay. It's not supported anymore, but the customer needs to keep that running at any cost. We're not going to put an agent there, right?
No.
So how do we handle this case?
So those kind of policies might make sense to also replicate a subset of the policy into some sort of infrastructure device that you can put in front of that mainframe. If you can't touch it, if it's something that you're never ever going to make any software changes on, you could take a firewall, you could take a switch, and you could apply the same policy that Tetration would put on the host, on that firewall, or on that switch. In fact, you can use the Tetration Kafka stream to get a copy of that exact policy that we would place on a host-based enforcement, but you could replicate that into a firewall instead.
So in your recommendation, in this scenario, let's say, because obviously no one will want to disconnect the mainframe and to move it around. It's connected to a switch. So when we talk about micro-segmentation, and you should not necessarily micro-segment the network, that seems to be like an exception, right?
Yeah, there's always exceptions to the rule. And in general, we would recommend if you can do the host-based enforcement, then you can back off the level of segmentation on the switch. But that still gives you the option to continue micro-segmenting certain segments of the network. If there are bare metal segments where you can't actually ever get an agent, that's where the relationship between the host-based enforcement and the infrastructure enforcement can really show its power.
That sounds good. So I guess it's the 80-20 rule, basically. 80% we're going to handle through the mainstream systems, which are going to be the host agents on the platforms, and 20% will be exceptions in that environment. Which is the question, actually, do I actually need to enforce here if I can enforce everywhere else? Like, let's say I have, like, I don't know, 70% of our workloads are enforced, and 30% are not or cannot in that environment. What would be your recommendation there?
So we actually designed the Tetration enforcement around the immunization concept. Once you get to a critical mass of people that are immunized, you'll actually start to protect the entire population. And it's the same with the Tetration policy enforcement. Once you get to a critical mass of workloads or hosts that are enforcing policy, even if you have some that aren't actually running that policy enforcement agent, there's not too much to worry about. And the reason being is that we enforce policy both exiting a workload and also ingressing a workload. So in this example, if we had a Red Hat Linux server that was speaking to that mainframe, even if we didn't enforce policies in the network for that mainframe, the Red Hat workload would actually control its egress policy to that mainframe. In the same way, if I had that mainframe communicating with a Windows Server machine, and that Windows Server machine was controlling the ingress policies, the traffic coming into it, it would decide if it's going to allow or deny that mainframe to speak to it.
I see. First picture that comes to mind now is Star Trek with shields up. So
exactly.
I can see the idea. So the idea is if I take any workload here, what the micro-segmentation is doing with the agent is actually just building out a shield around each one of the workloads.
Yes.
And so if I understood right what you're saying, this is actually blocked just as this is blocked.
Yes.
Okay. So that's pretty cool. I mean, so depending on the criticality of the asset, obviously I don't think our recommendation is don't cover them.
No.
We're not that crazy. But our recommendation is if those assets are in an environment which is well covered, except for those guys, you can potentially put them a little bit farther down the line for enforcement
Yeah.
in there. If those are your critical assets, you still probably want to think about it, right?
Mm-hmm.
Sounds good?
Yeah?
Do you see anything we've forgotten, Tim?
No, I think we've pretty much covered all of the different data center ways that we could enforce policy. We could also enforce policy between workloads that are on premises and in a cloud provider as well, without having to deal with cloud provider policy groups.
Oh, so you're saying, let's put, I'm with OVH this week.
Okay.
Yeah. I don't get any kickback. I just want to make that clear, Tim.
French cloud is best cloud.
Exactly. Man, we're the best, full stop. Let's say I have a workload here. It's running inside my OVH cloud. This OVH cloud is now connected to my firewall in the same way. What you're saying is, despite all the controls that are available in the cloud, if I want to, I can just deploy an agent here. Actually, sorry, agent was black. Stick to a bit of color. I can stick an agent on the workload, and I can still control the policy from end to end.
Yes. So, as customers start to see the explosion of the number of clouds that they're using, we're seeing it coming up time and time again that there's too many different policy types to deal with. Each cloud provider has a different way of enforcing policy. They expose a different API, and translating between all of those different APIs, the different policy types that are available, and the scalability concerns is really causing an operational nightmare. So we say that we should apply the same concept when it comes to enforcing policy in the cloud. Use the native cloud provider capabilities to control traffic coming in and out of that cloud VPC, for example. But the actual individual workloads, they can enforce policy via titration, and that means you'll get that same flexible microsegmentation policy enabled whether or not you're talking about an on-premises workload or a workload in the cloud.
That makes sense. That's a thing we didn't talk. I don't know what's their equivalent to lambdas, but they most likely have one. So if you have a lambda here, I still feel like it's Half-Life every time I draw this sign. It's a real problem.
I'm still waiting for Half-Life 3 as well.
That would be funny. We could make a video on that.
Yeah.
If I have this guy, that's looking more like a giraffe than Half-Life actually. But anyhow, if you had this guy there, obviously we can put an agent on a lambda. I mean, that's just the way lambda runs. It's a bit of code.
Yeah.
So, is that an example where you will actually use the native construct of the cloud
Yes.
to do that?
Yeah.
Okay, and that would be through the Kafka stream.
Yes.
Okay. So Kafka stream would apply to Lambda, to the firewalls, and the switch if we wanted to in there. And I guess there are partners between you'd work for that, or you could build it yourself. Nothing. There's no hard rule on that topic. Anytime you can actually deploy or control an OS, so that's valid for AKS, EKS, GKS, all those guys, and so on. You should your favorite route should be the software agent.
You got it.
Okay.
Looks like we've touched on everything, right?
I think so.
Okay. Well, thank you for joining us in our discussion on where you can enforce policy. I hope you found that useful. If you would like to find more information out about titration, please visit cisco.com/go/titration.